Hello and welcome. This is Erik Sofge moderating for MIT Horizon. Thank you all for joining us today. We're lucky to have with us Weisong Shi for a discussion about the future of edge computing. Weisong Shi is a professor of computer science and the associate dean for research and graduate studies at Wayne State University, where he directs the Mobile and Internet Systems Laboratory and the Connected and Autonomous Driving Laboratory. He's also a distinguished scientist in the Association for Computing Machinery, an IEEE fellow, and in 2019, he was lead editor for IEEE's special issue on edge computing. So thanks for joining us, Weisong, and let's get started. So to start us off, I wanted to first see if we can establish exactly what edge computing is. So how do you define it, and why are organizations interested in it right now?
Thank you, Eric. Yeah, thank you very much for having me. It's an honor to have this opportunity to share with the community about the edge computing and the future. So go to your first question. I know there is a very general understanding from the community is that we process the data at the as close as possible to the data sources. But here, I would like to give a sort of a official, the definition, which was originally come from the paper I wrote in 2016. So here we define edge computing as the enabling technologies that allow computation to be performed at the edge of the network. Here, edge refers to any computing resources, such as CPU, network, storage resources along the path from the data sources to the cloud data centers. So it is a continuum. It's not like a one device, as some people expected. Here, the computation involves two directions. So including the downstream that the computation on behalf of the cloud services, and also the upstream from the Internet of Things, the data, and then all the way on behalf of the IoT services. So I think it's very important to know that the edge computing is not just one direction. Actually, it's two directions. Yeah, that was the sort of the definition I would like to share here. And you're asking why the organizations are interested in this. That's actually perfectly matching to that definition I shared just now. For example, as a cloud provider, Amazon, Microsoft, and Google, they will be very interesting to push their services to the edge as close as possible to the end users and where the data generated. For example, Amazon, Lambda computing and etc. And then at the same time, as the upstream, you have a lot of data collected at the field, either a field at a smart home or maybe in the manufacturer and etc. In this case, you want to do a lot of computation as close as possible, to provide some extra services. In this case, like smart manufacturer, they are not really coming from cloud, but they come from, we have data. We want to do some local processing here. So that's why there's a lot of organizations interested in this from both directions.
Okay, so it seems like obviously cloud and edge are very related. There's a lot of overlap. In a best case scenario, do you think edge computing would support cloud computing, or would it replace it essentially? Again, only in a given application, obviously not replacing the entire cloud.
Yeah, I think that from the beginning when edge computing was first proposed, that around 2015, then people always ask this question: is this going to be something new, going to be replace the cloud? I don't think so. That edge computing is a extension of cloud, and it complements with cloud very well. As you can see that the cloud, the beauty of cloud is they have a global view. Imagine you have an organization, is a global organization. So the cloud has a global view of everything, what's going on with the multiple factories. For example, picking a manufacturing example, they have the global view, then they can make some macro kind of decisions, some data, machine learning models and etc. However, the edge can help them to say, well, I want to do some localized, processing. I also want to have some customized design and this. So this will be a perfect example to running this on the edge. So in some cases, one of the benefits of edge computing is increase the reliability or availability, per se, because if you purely rely on one data center, sometimes if there is a network issue, or maybe there's a server down, and then the whole system, the service will be interrupted. So with multiple edge, deployed in the different geographically, for example, then at least you can have some sort of services still available, even when the whole cloud is out. So I think in this case, they actually, I would say, edge is an extension of cloud, but then make it much more the penetrated to our life.
Okay. And is there, sort of strictly speaking, are there examples of edge that don't rely on the cloud at all?
Yeah, I think that is, it is possible. For example, if you want to say completely don't rely on that, it's possible. For example, in some of this larger warehouse, which I'm aware, for example, I'm not sure if Amazon is doing that, because Amazon obviously they have a cloud, but in some of this, like Jingdong, JD is one of the big online in China. They have this big warehouse, and then within the warehouse, they're putting an edge computing there to coordinate like 400, autonomous robots, which is sitting there to coordinate them. In this case, they don't really need to rely on cloud. They can perfectly to execute themselves, improve the efficiency for that purposes.
Right. It seems like, oh, I'm sorry, go ahead.
No, sure. Yeah. I think that's the case. And also in some scenarios, like in the disaster, in a disaster areas, and then you sending a lot of vehicles coming in, probably you want to using a cloud, but it's not available at that time. So in some of these scenarios, it is. Yeah.
Okay. Yeah. It seems like in that example of the warehouse robots, using the cloud could almost be a problem because there'd be more of a delay in, sending information and receiving it, whereas the edge seems like that's one of the main advantages, right? Is that speed of processing and sort of less or data being sent over a shorter distance, right?
Right.
Okay. So okay, you mentioned Amazon. One of the things that we've been looking at with this topic is this notion of companies like Amazon and Verizon, other sort of partnerships where companies are creating what we're calling sort of public edge infrastructure. So you might have edge servers that are placed in or near a 5G tower or other places where sort of nearby users can access them. Do you think that sort of approach is eventually going to become the default for how most people sort of interact with edge resources, or is that just sort of one part of a larger picture?
Yeah, I think that is probably just one part of the larger picture, because as you know that to answer that question, let's first starting with look at in the future, where are the data, where are this data generated? According to the Gartner, by 2025, 75% of the data generated on this planet will be outside the cloud data center. So this doesn't mean the cloud center is some people asking, oh, are you going to move in the data from cloud to the edge? Oh, that's not the case. So cloud will be still going to be increasing. However, at the edge of the network, you're going to generate the path, the pace to generate the data is much faster than the growing on the data center. So because of this reason, that you can imagine that this is a huge market here. Right? Because of 75% of the data need to be processed. That's why there's a lot of potential players going to be in the edge computing field. The two you mentioned, Amazon, which represents the cloud providers, obviously they have their incentive. They want to continuously grow their business. They want to deploy these things as much as possible. And then for you also mentioned Verizon, AT&T, this telecom, globally, that all these telecoms, including Vodafone in UK, Telefonica, in Spain, and China Mobile, and etc. In China. So those companies, they view this as a great opportunity for them because so that they can deploy those edge servers so that serving as a resources. All right, so that is from their point of view, and we already see that AT&T in China, Unicom, they have been starting deploying these things. However, I noticed that there is some other potential players recently jumping in. For example, that the what we in US we call for example DTE Energy, like a smart grid, and
Oh, right.
yeah, especially in China state grid, because their view is very simple. Um, where's the data where's this data generated? Basically, is those data is generated by most of the things, and they have to have a power, correct?
Mm-hmm.
So once you have a power, that means they already have a computing resources there. Most of the power controllers that they can add a little bit of computing resources, that would be a perfect places for the people to do that, to put the edge computing resources there. So for example, in China, what happened is, because China is very similar to New York, you have a lot of these high-rise apartments. And
Right.
for in one of the division, you could have like 30,000 residents in this area. And then they're building these computing resources next to the power entrance of the I don't know how to describe that in the but what I mean here is
Yeah.
you have to have some sort of a switch, right? Then you put in the computing resources there and can serve this whole area. So that
Mm-hmm.
is another potential player. And actually, State Grid in China is invested heavily in this. I haven't seen too much in the US side. Probably is because of the density here is not as dense
Right.
as they used to see in Europe or in China scenario. So that's why my answer to your question here is telecom and the cloud. Obviously they want to do that. But there's other potential. There's another potential player here is the city government. Maybe
Mm-hmm.
through some of the private sector. The reason here is, in addition to the cellular tower, we also see a lot of traffic lights. One of the work now recently we deployed at the Wayne State campus is we put in the edge server on our 5 intersections connected to the traffic signal. And
Okay.
then to support our campus, that we coined this as a connected vehicle edge computing live test bed, because the students, your phone, you can anyway, Wayne State campus already have a Wi-Fi coverage, even the Middletown area in Detroit. So you can connect to this edge servers, and then it can send you a warning about for pedestrians, a warning for the traffic, and etc. So in this case, you can see that this is not necessarily deployed by either cloud service or telecom. This actually maybe come from traffic transportation area.
Right.
So those are all these people, all these different industry sectors. They see there's a huge potential here. So I view this is that eventually you're going to see a variety of edge providers, and then that's good for our customer, because when you was driving, working through the city, you have an opportunity to reach a different type of this the resources.
It's interesting because it seems like the common thread there in what you're describing, if you have sort of traffic infrastructure, electric or power infrastructure, energy infrastructure, and then also the sort of telecom infrastructure, it seems like maybe more than even cloud, which edge is sort of, again, kind of compared to cloud a lot. Cloud, the infrastructure issue is handled by big providers often who just buy like a large plot of land and build a huge facility. In this case, it seems like we're up against this infrastructure issue, right? Where it's who has the real estate, who has the sort of right of way, who can place edge servers, edge computers in a place where people can get to them. But do you think, I guess I'm curious, that obviously infrastructure issues pose their own challenges. Are there other challenges or I guess, what are the other main challenges to sort of increased development of edge computing?
Yeah, this is a great question because it's a natural follow-up with that. Since we have a variety of the infrastructure providers here. And then the key things, the main obstacle, even today, is about how can I develop a program can use it. You know, when I develop a program, for example, we are computer scientists here. So I want to write an application today. Let's say if I want to write an application to running on my phone, connected with one of the edge server here, I don't have a immediately easy way to do that, right? So I think those are something that right now I view that probably potentially in the next 5 years is going to be see a big improvement here. Right now, we have seen that, for example, Amazon introduced their own Lambda programming interface, and then some open source foundation such as OpenStack. Originally was a very success in the cloud. Now they're moving to supporting Edge. And then Linux Foundation, LF Edge, also come with this Adriano kind of programming framework, is trying to define several scenarios, how to connect it and connect it from the device to the edge and then to the cloud. So I think once we see some of this, programming interface is clearly defined, and then once we see those infrastructure has been deployed there, this is exactly what we plan to do in this year, 2022, because we have infrastructure is already put there. Now we want to choosing one of the programming infrastructure, programming framework there, so that we can allow the students to write code to this. So I think, sorry about that. That was the worst thing, Yeah. Normally you don't have this phone calls at home.
That's true.
Yeah, sorry about that. Yeah. Once this barrier has been, we can pass, and then you will see a blossom of the applications going to be deployed here. I think that's we really enter the edge computing era.
Okay, that makes sense. So in terms of the industries that you think should be most interested in edge computing right now, I mean, it sounds like maybe 5 or 10 years in the future, or at some point, there won't really be a choice for a lot of organizations. It's just like with the cloud, you're sort of using it without thinking about it. But are there industries that you think where organizations in those industries should actually be paying close attention to edge specifically, and maybe even sort of investing or preparing for it, again, in a specific way, not just in the sense of knowing that it'll arrive eventually and become more common?
Sure. I come from academia, so I maybe, and also that have a little bit of bias on this, just a warning at the beginning, because my own research is on connected autonomous vehicle. The reason I started working on this back to 3 years ago, because I view this is an area, that they will have to rely on edge computing, moving to the next level. The reason is that traditionally the vehicle, even the business model, if we're thinking bigger, in the last century, because I come from Detroit, Ford, GM is here. If you think about the last century, vehicle itself is only like a transportation tool. What the business model is, you and I go to a dealership, buy a vehicle. That's it, period. That's how the way they make money, right? But now if you're looking for in the next century, the things here is changing significantly, because now how do you going to make a money, the business model behind the future vehicles? As you can see, Tesla recently increased their price for the autopilot from 10,000 to 12,000. What that is a very good indication here is in the future, you also OEMs, you're getting a vehicle, all right? Let's say you get a vehicle at the price X. That's just the beginning of the story. So that continuously, they will give you more and more software-based options. And then the vehicle is all connected. And then that they will continuously need to update their vehicle, update your software, and either add the new function you want to add, or maybe they need to update the current software already, for some certain functions you already purchased. So in these cases, the whole business model is completely changed, and that's also putting a huge challenge for the infrastructure. Auto industry, before they don't really care about the infrastructure. The only one is the dealership, I guess. And now there's very different. All the OEMs have really thinking about how can I maintain these connections, services with all of the vehicles that I own. For example, Toyota alone, they might have like definitely close to several. I don't know the exact number, but they probably have like a 50 million vehicles, right, actively running on the road right now. So they need to maintain this type of connectivities and etc. So for them, edge is a very important infrastructure. I'm so glad that actually Toyota took the leader, created this so-called AECC, stands for Automotive Edge Computing Consortium. So right now is a big consortium is pushing that how edge computing going to help the automotive industry to moving forward. All these major hardware telecom companies are part of that consortium. So this is one of them. I see that they definitely need to pay attention to that.
What do you think is the main advantage or the main benefit that edge can provide specifically to automobiles?
Right. So the advantages that's actually applied to almost all the benefits that the edge could potentially brought. The reason is one, let's pick an example. If a OEM want to maintain, collecting data from this 10 million vehicles, and then the one thing is who's gonna pay for this data collection? It's a cost. Cost for them is very big. If you imagine that you and I have a vehicle and we need to pay $50 a month just for them to collecting data, we were not going to do that, right? So they have to pay it. But this for them is extra cost. So the first thing is what the edge can do is edge can significantly reduce those traffic, the bandwidth requirement, because you can do some process on board on the vehicle and then sending any very limited kind of data, to the, sending back to them, and then they probably can cut this cost to dramatically. That's the first one. Now, second is about the scalability issue, because if you imagine that each vehicle every 5 seconds you're collecting all the engine, tire, and many other sensor data, that itself is a huge amount of this in terms of connections. So none of them is able to do that. So they have to purely rely on the today, for example, with some cloud providers to help them to store the data, collecting the data and storing the storage and etc. So those are the things that they also are going to have a huge benefit. The other thing is about so far we are talking about is what I mentioned earlier today is upstream. You're collecting data up, right? So I want to use this as another example. It's for the downstream. Why? Because also as I mentioned, those softwares, because now we call the software-defined vehicles, all the software needed to be updated. So that means you have one software, now you need to update in 10 million vehicles. So what are you going to do? So this actually is a very good example. Edge can help to distribute it. And that's the original idea of the content delivery network, right? So it's you deliver the software in vehicle side, they call the over-the-air, OTA, the over-the-air kind of software update. So all those issues they could potentially benefit from the edge computing.
Okay, that's interesting. One thing that you mentioned there was this idea of using edge to sort of lower the amount of bandwidth needed for lots of transfers. And it seems like in part the idea for edge is that you'll have certain applications like the ones you mentioned with cars, but other ones maybe for security or other things where you handle a lot of the data locally with edge processors, and then you only send a smaller amount to the cloud or elsewhere. But that, it seems like one of the advantages there could be increased privacy, right? Because you could have an organization that sort of has better control over the data of their users and what they're sending out, what they just destroy after using it, all that stuff, just more control. It seems like it increase privacy. But I'm curious about, and this is kind of a future sort of notional issue still, but it seems like it's come up with experts, that there is this potential risk for security where if you have these public edge infrastructure resources, you have them in streetlights or 5G towers or other places that, unlike a cloud data center, you could maybe get to more easily. It's not the same level of security and all that stuff that you'd have at like an Amazon cloud data center. Do you think that it's true that that this is a genuine sort of concern going forward, that having sort of edge infrastructure that's out in the world and more reliance on edge could lead to more sort of security risks, like more attacks where a hacker or whoever could literally just break into a sort of a public box and have physical access to edge infrastructure? Is that a real concern, or are experts kind of just reaching?
Well, I'm not a security expert, but let me trying to understand this. As we know that the edge, first, I agree with that, that there's a potential that particularly the physical security threat, right? Because now you hang on in a traffic light, people, even if they can physically attack it. But we also need to notice that, attack on, one of the edge devices compared with attack in a cloud data center, the impact is completely different. Imagine you can destroy one of the traffic lights. So what's the impact? It's only in this small region.
Right.
So you need, the cost to do this attack, and the impact of this attack is also dramatically, reduced. So say if you and I want to physically attack, how many edge server we can attack per day? You physically destroy them. You are not going to generate a huge impact here. So I'm not really too worried about that, given that, hey, you put in this with this, traffic light. So why we haven't seen so many people attack a traffic light? So there's other similar things there. So I'm not really worried about that too much in terms of this physical security. Yeah.
Got it. Okay, that's a great point. So I think the last thing I wanted to ask you about is about the future of edge when we look maybe 5 years, 10 years out. Are there sort of major developments or major sort of changes that you see on the horizon? Or is it just a matter of, well, it'll become more accessible because there'll be sort of more infrastructure available? Is there anything more dramatic or anything like a trend or, again, a development you think is worth keeping an eye on?
Yes. I think that, edge computing, since it's already been here, particularly academia that already been talking about this for about 5 years. So I think now really a good trend is keep an eye on your own industry, sector, because as I mentioned earlier, auto industry right now seems like already realize this is very important. So I'm sure that maybe 5 years later, they will have some really good progress. And then in some sectors, they just realize that, for example, in the health domain, again, because of the privacy issues, also the data cannot moving out of the organization. So health domain also starting to look at this. I've been interviewed a couple of times by the health magazines. They also believe that the edge is going to change them significantly. So those are the factors. The interesting thing is, I don't expect that all these industry sectors will be moving at the same path. Same path. It's dependent on the way how they realize it is important for their business, right? I think for them, business is number one. But I do see auto manufacturer and then particularly smart home, in these areas that there is a lot of, ongoing things. Smart home, you already see, it's going to be penetrated to our life. You didn't really realize that. For example, many of these the smart home gateways today are doing edge computing for you now, but you just haven't realized that. So yeah,
that's great. All right, well, I guess we could talk all day, but we're out of time now. So thanks again, Weisong Shi, for all of your time today, and thanks to everyone who's joined us. Make sure you give us feedback in our survey, and visit us at horizon.mit.edu for all the latest on emerging technologies. And we hope to see you at the next event. Thanks again.
Thank you for having me. Yeah,
absolutely. Our pleasure.